Solving absolute values. So here we're going to look at how we can solve equations with absolute values in them. Let's start off with a simple one. The absolute value of x equals 3. And in our introduction to absolute values video, we spoke about having the absolute value of an unknown, and you need to take two cases. Because we don't know if x was originally positive or negative to get that value of 3. So we take two cases. We take one where everything in the absolute value is positive, or one where everything in the absolute value is negative. So everything in the absolute value was positive, or everything in the absolute value was negative. And we go ahead and solve those equations. So positive x is just x, so x equals 3, and negative x equals 3, times both sides by -1 to get x equals -3. So we get our final answer of x equaling plus or minus 3. So we get two solutions. And that makes sense, hopefully, that if x was 3, the absolute value of 3 is 3. And if x was -3, the absolute value of -3 is also positive 3. So those two values hold true. Let's look at another one. The absolute value of x minus 2 equals 4. So again, we just take two cases, one where the absolute value is positive and one where the absolute value is negative. So if everything in the absolute value is positive, we'd get that equaling 4. And if everything inside the absolute value was negative, we'd get that also equaling 4. So here we just get x minus 2 equals 4. Add 2 to both sides to get x equals 6. This one I can actually divide both sides by -1 to get that. Plus 2 to both sides. So we get x equals -2. So we get our final answer of x equaling -2 or 6. And we can go ahead and sub that in just to make sure. So if x equals -2, we'd have -2 minus 2, which is -4. The absolute value of -4 is 4, so that works out. And we have 6 minus 2, which is 4, and the absolute value of 4 is also 4. So that works out nicely. Let's look at one more example. This time we have the absolute value of x plus 1 equaling the absolute value of 3x minus 3. Well, remember, for absolute values we have two cases, one where the absolute values could be positive or negative. But because we have two here, we have four cases to consider. One where the first absolute value is positive and the other absolute value is positive. One where the first one was negative and the second one was negative. One where the first one's positive and the second one's negative. Or one where the first one's negative and the second one's positive. But if we look a little bit closer into these, when you have two negatives on each side of the equation, we could divide both through by the negative, and that ended up being positive. So these two cases are actually the same. And when you have a negative on one side of an equation just equaling one other thing, it doesn't matter what side the negative's on, because think about these equations, we could always change the left-hand side and the right-hand side, so these two are also the same. So our four cases ends up only actually being two cases. We can just consider one where they're both positive on each side, and one where just only you make one of them negative. So we can go ahead and do that. So again, even though seemingly looks like we have four cases, we only really have two. So we're going to do one with positive equaling positive and positive equaling a negative. So if both sides are positive, we just get x plus 1 equals 3x minus 3. And if we make the left-hand side positive and the right-hand side negative, this will be our second case. And we just need to solve both of these equations. So let's minus x from both sides. So we get 1 equals 2x minus 3. Let's add 3 to both sides. Then divide both sides by 2. So we get x equals 2. We can expand this negative on this one. So we get minus 3x plus 3. Let's go ahead and plus 3x to both sides. So we get 4x plus 1 equaling 3, minus 1 from both sides, then divide both sides by 4, will give us x equals a half. So we get therefore x equals a half and x equals 2 as our final answer.